Hello, I'm Mr. Seidel. I teach high school math at Glenwood High School in New Boston, Ohio. And in today's lesson, what we're going to try to find is a value of an exponent in this type of expression. Okay? So, if you need to pause and write down something, that's fine. But at any rate, let's go ahead and get started. The expression x squared times the quantity x minus y raised to the third minus y squared times the quantity x minus y raised to the third can be written in the form x minus y all raised to the a power times the quantity x plus y, where a is a constant. Okay, so we're going to be all about finding the value of a. All right, where's a? Just like Pretty Little Liars, right? All right, so what is the value of a? Okay, all right, so I'm going to scoot this over a little bit. May have to pick up just the whole thing. Try to keep it to where, you can see both boards. Okay. Now, what we need to do is we need to go back to the previous problem, okay, which was this, and try to rewrite it in this form. Okay. Now, here's some things I want you to consider. We've been talking about factoring expressions, especially the quadratic stuff. Okay. Now, this is a polynomial that has factors already given. Okay? If you recall, you take this times this, and then you're timesing something else by the same thing. This must be a factor. So picture x minus y raised to the third as just some other letter. Okay, let's call it z. Okay, this is what z is. This whole thing right here. Okay, so that is one of the factors. Okay, now what I'm going to do is I'm going to rewrite this as x minus y raised to the third. Okay, that's a factor. Greatest common factor. Pull it up. Okay, well, what's left? All right, well, in parentheses, if I take this out, what is left? X squared minus, if I take x minus y raised to the third out, like I did right here, here's my greatest common divisor, okay, which is a factor. Okay, what is left? Y squared. Okay, now so far, what I've got to is I have something here that matches this. Okay, and I have an exponent right here. But, okay, this expression is said to be written in the form x minus y raised to some power times x plus y. Well, where does this x plus y appear? All right, so I got to think that it's got to appear right in this factor. Okay, now what we have right here between this parenthesis and this parenthesis is known as a difference of squares. Okay, and that is pretty simple to rewrite. All right, what you do is you take a difference of squares. Okay, a difference means minus, and I'm going to split that up. I'm putting a minus here and a plus here. Well, if I have a difference of squares, whatever this is, square root it. Okay, what does that mean? Square root of x squared is x put that here and here, and do the same thing with y, difference of squares. We need to square root this. This is how you break things apart. Well, the square root of y squared is just y, so I'm going to put place y here and y here. Now, if I bring this all together, this is what I have. Okay? Now I'm going to use a different color. If you see right here, I have x minus y raised to the third power times another x minus y. Now that's only being raised to the first power there. But if you remember rules of exponents, if I have a base to some power times another, the same base by another power, what do I do with those exponents? Well, the rule is you take a, your base, and you add the exponents, which in this case is going to be a to the fourth power. So I need to apply that exponent rule to this situation. All right? So my base is x minus y to the 3 plus 1 power. I got 4 x minus y's that I'm multiplying together. Okay? And now I have the x plus y, I can bring it down. Well, here's this. Okay? And then here's my x minus y to some power. Well, this exponent is the a that I am looking for. Okay? So my a is going to be 4. All right? So let me sit in my chair a little bit. All right? So as you can see, a lot of exponent rules come into play. Okay? Stuff that you've had since 7th, 8th grade. All right? Now, what we're going to do is take, another expression. Okay? We're going to find the value of a, just like we did here. Let me get my cheat sheet out. Okay? And I will erase the board here. All right. About done. This will be the last example. Okay? But it is what it is. We'll be done after this example. Okay? So let's say if, okay, now this is going to be a little crazy here. The square root of the cube root of the quantity x plus 1 to the 5th power equals x plus 1 to the a power. So we're all just trying to find a. Okay? All just trying to find a. Okay? 4, we got to write this down for definition, or it would not exist. X is greater than or equal to -1. Okay? We got to have that. Okay? Because if we let x be less than -1, we're going to get imaginary complex numbers, which we don't want to deal with. That's why that is there, to avoid the negatives. Okay? We're going to say, what is the value of a? Now, if you recall, okay, if I square root something, let's say I took the square root of x, or let me pick a different letter. Square root of a. Well, how did we rewrite that? A to what power? 1/2. Okay. Now, so let's say we have the square root of a to the, or the cube root of a. Well, that equals 1/3. Okay? It's understood that this square root, if there's not a number there, it's 2. Alright? Inside the radical. Okay? Or right there by the radical. Okay? Now, let's say we have this. So if I have a to the 3rd power and I square root that, well, what does that become? A to the 3, a to the 3rd power times 1/2, well, that equals a to the 3/2 power. So whatever your number is being raised to right here, that's going to become your numerator. Okay? With that being your numerator, we have the number outside the radical, the square root, and we can put that together. This is going to be your denominator. Okay? Now in this particular problem, we need to go inside out with this. Work from the inside and expand out. Okay? So we're trying to find A. What is this going to be? I want to rewrite this in this format. Okay? That's a lot of writing. Alright? Let me get my notes here. It's a lot of writing. So let's go ahead and begin. Let's start with just the cube root of x plus 1 to the 5th power. Let's rewrite that part first. Okay? Let's just worry about that part. I can rewrite this as x plus 1 to the 5/3 power. Okay? Numerator here, denominator here. Okay? Right here. Now, I took care of this. So now what do I have left? Well, I'm going to write the square root, the big square root over here, and square root in this whole thing, which we got right here, which is the quantity x plus 1 raised to the 5/3 power. Now it's understood that that's going to be a 2 because there's nothing there. It's a square root, so I got to pretend it's 2. Let's rewrite this. Okay? I can take this out. X plus 1, 5/3, that's what it's being raised to. I'm going to times that by 1/2. Okay? Well, what does that equal? X plus 1. 5 times 1 is 5/3 times 2 is 6. Okay? I have it in this form now. I got x plus 1 right there. Well, what does A equal? A equals 5/6. Okay? We got to be good at manipulating these. All right? Well, thank you for your time and patience. I'll see you tomorrow.